very first drive that I sold 25 years ago was $25,000 for a 1 gigabyte drive.
Wow.
So yeah, if you just see how much, in 25 years, right? I mean, 1 gigabyte today, you're looking at 8, 9 cents, 10 cents maybe for a high-end drive. So, the world is changing rapidly when it comes to memory and storage technology. And I don't think that, we're anywhere close to the end of that. So very exciting. And, if you like technology, this is certainly an area to keep track of.
Good morning, everyone, and welcome back to what is the second episode for 2024 for the Making It Happen by Sims podcast. Today, I'm joined by a very special guest, someone I've thought about inviting on for a while, and thankfully we've been able to make it happen. So today, I'm joined by Esther Spanjer, who's Micron's Enterprise Business Development and Director for EMEA. Esther, how are you?
I'm good. Good morning. Thanks for having me on this call. I know we've talked about it for a while, and I'm really excited to be here as well.
No, thank you. It's been a long time coming, but yeah, no, really, really great to have you on, and looking forward to a good chat. So for those of you that don't know, and you probably won't know, but we at Sims, we work closely with Esther across Europe and specifically the UK around driving enterprise memory storage for customers there. And for those of you that don't know Esther, her career actually spans probably more than 20 years, and Esther can correct me if I'm wrong shortly.
Even longer.
Even longer. So I think it's probably better that you, in a bit more of your detail, is to give a little look back at your time in the industry and a bit more detail around your role right now at Micron.
Sure. So I've been in the flash and storage and memory industry for my entire career, which is more than 25 years by now. I originally started for a small Israeli startup company called M Systems, and you may not know their name, but you remember them from the biggest invention they had, the USB flash drive. They actually invented that product. Since then, I've worked for a variety of flash and memory companies, SanDisk, Western Digital, some other startups, and then for the last 5 years, I've been working for Micron. For Micron, my primary role is business development in Europe, with a specific focus on the enterprise data center world. So any storage or memory that goes into a data center, into a server, into a data center, that's really where I try to enable and facilitate more Micron products. And I have maybe one other. I have a degree in electrical engineering. I have a master's degree in business, and my roles historically have been ranging from technical support to product marketing to FAE manager to marketing to sales and business development. So pretty much, the entire span, but, anything that sits between a customer and engineering, if you will, that's kind of where my focus has been for my entire career.
That's great. I didn't know about the education part and where you've delved into each area there. So that's quite interesting. And have you always been involved in enterprise, or have you dabbled in consumer, or has it specifically been data center sort of areas that you've been involved in those roles?
So I've done mostly B2B. So originally flash storage wasn't really focused on the enterprise. It was more focused on industrial and military purposes, because 25 years ago flash was so expensive. A lot of embedded kind of applications. But, for the last 10 years, I would say 10, 15 years, it's been primarily enterprise focused.
Great. Okay. Well, it's very much enterprise and data center that we're going to be turning our attention to today in this conversation. As we step into 2024, the challenges of data centers and those using and owning them are probably more pronounced and more complex than they've I'd say ever been. Evidently they're hubs of digital activity, the backbone of our online existence, if you will, and the growth of that consumption really does call for so much more in terms of efficiency, security, and sustainability. So I think let's kick off by just dissecting some of those challenges a bit more. And I think the main one, I believe, is probably just the sheer amount of data, that the explosion of it, right? It's pretty obvious that this is probably the main challenge, and you can correct me if I'm wrong, but I think I read roughly that somewhere that it's around 23% each year increase for data. I think there's been some anomalies in there,
Yep.
like where it's been 54 or 55, but this is probably what it's going to be steadily for the next 2 to 3 years. So with this and coming from a memory and storage angle, Esther, what solutions are we seeing in the market right now to deal with these challenges? And I suppose specifically for this part around capacity and scalability, and we'll come on to efficiency soon.
Sure. So, yeah, you're absolutely right. The amount of data that the world produces as a whole doubles about every year. And so, what do you do with all this data? You need to store it, you need to compute it, you need to manipulate it, and then you need to spit out, whatever it is that you were doing with that data. So that requires a lot of capacity, but it also requires a lot of computational capability, not only from a CPU perspective, but also from a storage and memory perspective. So what we've really been seeing, over the last few years, and what we will continue to see accelerated is, faster storage, higher capacity, larger bandwidth in memory, higher capacities in memory. And so, and then efficiencies of how do you utilize those as best as you can? Do you get very, very close to the CPU or the GPU, or are you actually trying to split them out and have separate banks for storage versus locally within the CPU? So those are all the kind of the trade-offs that you have to do within a data center to find the most optimal solution for for your requirement. Of course, the biggest trend that is driving a lot of this at the moment is artificial intelligence. Right, that is the the one thing that everybody is talking about, for the last, I would say, year, 2 years, and the expectation is that 2024 really will be the year that AI servers in the data center are really going to kick off, and and they require some very, very special optimization and a ton more storage and memory. The analysts are saying that an AI optimized server can get up to 3 times more storage and up to 8 times more memory than a standard general purpose server. So 3 times more storage, 8 times more memory. Of course, that requires a lot of optimization of efficiencies and trade-offs in terms of how much money am I willing to spend versus how much computational efficiency I'm looking for.
Yeah, and just in terms of capacity of those drives, and from a Micron or anyone at the manufacturing semiconductor level, are they really looking to sort of push these drives up in terms of, I think we're seeing drives at 30 to 60 terabytes now. Are these kind of drives going to be used in that AI sort of
Yeah.
environment, or is it still going to be smaller scale?
Yeah, so we're definitely seeing 30 terabyte drives and soon 60 terabyte drives. These are typically used for when you're looking at a data lake. When you're running artificial intelligence, there is multiple steps in that artificial intelligence that you need to kind of look before you can actually utilize the whole model. And the training model, the training part of artificial intelligence means that you have to have a lot of data sitting somewhere that you can then start to crunch and actually feed into the model to teach the model what it actually needs to do. Now, typically that data has been sitting on hard disk drives because they are the lowest cost, storage devices. The challenge when you do that with hard disk drives is that you now have a fairly expensive GPU-enabled server that is crunching this data, and the GPUs are substantially higher cost than any storage in your server. And when you use hard disk drives, it cannot feed the GPU fast enough, so you have GPUs sitting idle. And so what we're seeing more and more is that the hard disk drives are being replaced with high capacity SSDs, as cost optimized as they possibly can, so that when you're running these training models, you actually have the GPU utilization as good as possible, and you can crunch and make those training models run much faster. So that is certainly a trend that we're seeing, because the overall cost of the solution can be substantially lower when you're using a high capacity SSD versus using maybe lower cost hard disk drives, but you've paid a lot for your GPU that you then cannot efficiently use because of the speed of the hard disk drive.
Sure. And we'll continue that our conversation in just a second, but you just brought up hard disk drives there. And I just want to, just for our listeners who may or may not know too much about data centers and their usage things, hard disk drives are probably still going to have a place and utilization in data centers, right? So
Of course.
AI is one thing, and these super high capacity, well-performing SSDs are going to have a place for AI. But where do we see the future of hard disk drives in a data center?
I think there will always be a place for hard disk drives. There's been a lot of, I've been in this industry for, as I mentioned, 25 years. There was always the question, when is hard disk drive going to replace SSD? The same as the question is, when is tape going to die? And I don't think that any of them will. I think all of them will have a place. What we do see though is that the focus with hard disk drives is on larger and larger storage, capacity, and that is going to be more and more used for what we call cold storage.
Mm-hmm.
So, storage that needs to sit there, but that you don't have to, actively access. And then the more warm or hot storage will be moving on to SSD. So what you're seeing the hard disk drive industry doing is moving away from the higher performing hard disk drive. So 15K RPM hard disk drive are pretty much non-existing. 10K RPM hard disk drives are on their way out. And what you'll start to see remain is the 7200 RPM hard disk drives, in higher and higher capacities. And all of the, kind of higher performance requirements, even if it's just slightly higher performance, will be replaced with SSDs. Also because the minimum capacity of an SSD is, we're starting at 480 gigabyte, whereas, the lowest capacity hard disk drive is less than, I think it's 2 terabyte is the minimum capacity at the moment. So, when you're trying to look at, you need some kind of capacity, but you don't necessarily need all that capacity. Which, and at the same time, then if you take a hard disk drive, you also have to look at the power consumption of a hard disk drive, which is becoming, more and more important in the data center today. The idle power consumption of a hard disk drive is still substantially higher than the idle consumption of an SSD. And so when you're taking those two into consideration, is what you see is that, what used to traditionally be stored on hard disk drives is moving to SSD, and only hard disk drives are being used in where you really need to have a lot of high capacity, large storage capability for what we call colder data. So the overall hard disk drive industry, that's the trend that they're going after. The lower end of the capacity range is being replaced by SSDs, but I don't think we will ever get to a situation where we will not have hard disk drives in the data center and it will all be SSDs. I don't believe that that's certainly not in the next decade.
No. Okay. That's and I think the example there is tape and how that is still used. Right. Prominently as well. So
actually, it's making a comeback at the moment.
Yeah, no, I did see something on LinkedIn about some trends there. So, but again, there's different use cases for everything, right? Not everyone's a hyperscaler that's going to be using HBM or DDR5. And we'll get onto that a bit now, I think, and a bit more around performance and latency, I guess, and the need to process data for AI in real time and just make fast decision making. So I think you mentioned a few things there about high bandwidth memory, for example, HBM, and I know that's something that Micron are big on and they're producers of, right? So, let's talk a little bit about HBM and its uses and where Micron are at with that, and then we'll sort of move on to maybe DDR5 and how these technologies within the market set them apart from memory storages of the past, to be honest.
Yeah, so HBM is of course an amazing technology because it requires, it's the word stands right, high bandwidth memory. But this is a technology that sits very, very close to the CPU. It is actually, incorporated typically together with the GPU. So it is already part of the either the motherboard or the GPU module that is connected to the motherboard. So when you are configuring a data center, you already the HBM is not a separate component that you can kind of choose. It's already part of the GPU module that you're putting into your server. So this is clearly a large enabler for optimizing GPU capability. We have roadmaps to what is called HBM 1, 2, and 3 is coming out, but these are, if you will, chips that are soldered onto either the motherboard or the GPU module. So it's not a configurable item in your data center. It is already part of the the hardware as you either buy it or you design it, depending on whether you're a hyperscaler or whether you're more of a tier 2 data center that buys separate configurations.
Yeah, and I think especially as well with the growth of DDR5, I think I just want to talk a little bit about the types of data centers. From a lot of stuff of the technology we're talking about there, that'll be used at the top, right? So the Amazons, the AWSs, the hyperscalers will be starting to incorporate that technology.
Yep.
But obviously, and you can speak from experience in Europe and within the UK, there's smaller DCs at around 5 to 10,000 servers. We're not talking massive amounts. Where are they at with the technology from what you're seeing? They're probably trending some way behind. There's not quite a need to move to any of this just yet.
Yeah, so the what we would call tier 2 data centers, the ones that are in that 5-10,000 server range, they definitely always are running a few years after the large hyperscalers, for obvious reasons, but they are currently all moving to DDR5. So the motherboards that enable DDR5 have been starting to ship now for about 8-9 months, and so we're starting to see new deployments of servers in the market with DDR5. So DDR5 products came out about a year and 3 months ago or something like that. At the moment, I would say we're at about 50% share between DDR4 and DDR5. So we're starting to see more and more demand for DDR5, into these data centers. A lot of the DDR4 is still being used for upgrading existing infrastructure or refreshing existing infrastructure, but any new infrastructure that is being put into a data center today will all be using DDR5, as all the new motherboards and servers that are being sold today are DDR5 enabled.
Sure, and I suppose I'm talking a bit about that technology. I've read somewhere that was expected to be around 90% of data centers were actually using NVMe by this point, compared to SATA. And there's obviously reasons for that. Do you think we're anywhere near that figure still, or is there still a lot of DCs using SATA-based technology?
Again, here, I think you have to make a big distinction between the hyperscalers and, the tier 2 data centers. So the hyperscalers absolutely are all 100% on NVMe. You won't find, an Amazon or a Google that's still going to buy any SATA drive. But in what we call, the tier 2 data centers, so in the channel, those smaller customers, there's still a lot of upgrade happening with SATA. We still see, when we're looking at the amount of units that we are shipping in Europe, we're probably still shipping slightly more SATA units than NVMe. When you're looking at the capacity that we're shipping, so how many bits are we shipping, it is slightly higher on the NVMe side, and that's just simply because the average NVMe drive that we sell is higher capacity on average than the average SATA drive. But call it 50-50, 40-60, something like that. So SATA absolutely is not dead, but we are seeing eventually, in the next few years, it will slowly phasing out. And the reason for that is that the native support for SATA in the HBA for Intel is going to be, I believe it's 2026 when they stop that. And so once there is no more native SATA support, you will slowly start seeing that, that technology diminishing. So I think there's still a long tail for SATA, but it's not going to be forever, like tape, just because at some point, there will be no more motherboards that support SATA.
Sure. Okay. No, that's really, really good detail and very informative, I imagine. So before the next part I want to come onto is sustainability. But before we do that, so I think just to recap, sheer scalability, performance, these are the challenges that are sort of facing DCs. Do you think we've missed anything there? Is there anything else that you think, in terms of challenges out there for our DCs that we can cover? Because I did mention security, but again, if that's something at the forefront.
Frankly, I don't see a lot of questions about that with our customer base. For example, we have, we sell SSDs that enable encryption, but surprisingly, I only have a handful of customers that are interested in that. So I would imagine that the security is done on a different level and not on a drive level. So yeah, it's not a big topic in my everyday discussions with my customers. What is certainly more important is the power consumption. So a lot of customers, ask very detailed questions about, how much efficiency they can get from either DRAM or SSD. And just to give you an idea on the efficiency between DDR4 and DDR5, because of the different architecture of how a DDR5 module is built, it is actually about 20% more efficient in terms of providing performance for the same amount of wattage. So, if you would run both DDR4 and DDR5 at the same speed, which, we know we wouldn't, because DDR5 is always going to be higher speed. But even if you were to run it on the same speed, you can actually get, more efficiency out of your DDR5, just of the way the actual architecture of the module is set up. So that is, part of the reason why DDR5 is also becoming more attractive to customers, because it just gives you, more performance for the same amount of power, and, more efficiency, what we call, bus efficiency. And then similarly on the SSD side, the idle power and the time, you actually need or the amount of power you need to write data to an SSD, and the time that when you don't write data, how much power it needs, it's substantially better than a hard disk drive. So there is a lot of questions about, efficiencies of power and how do you really optimize that, especially in the last few years with the Ukraine Russia war, where prices of electricity went through the roof. Everybody was figuring out how the hell they can optimize their power footprint or their energy footprint as much as possible. So that's certainly a big discussion all the time.
Yeah, I can imagine. I think that kind of brings us on to our next bit around sustainability.
Yep.
I think for data centers more than ever, they're kind of seen as the bad guys, but we need them, and they do take up a huge footprint in the world. And I suppose for operators and facility owners, they've got two battles, right? So they've got the battle of the actual facility, the cooling systems, IO containment, recycling the heat, and actually how their data center is set up from an infrastructure perspective. But then also, there's another battle that how they can affect that within the server and the components that they choose. So I think from that perspective, I think you kind of just probably summed up there. It's an efficiency game, and what's available from Micron on the market now, SSD and DRAM wise, to actually help with that power consumption. And I'm sure you're ever evolving in that technology to sort of hit with that message, right?
Yeah, and I think many of our customers are taking even a step further, and they're actually trying to understand what the footprint is of their supply chain. So not only do they want products that help them manage their data center in the most efficient way, and with the lowest environmental footprint, but they're also looking at, okay, so, you're going to supply me with, this product, what did it take to actually produce that product? So we have a lot of customers are asking us for our sustainability and environmental implementation in our facilities, in our manufacturing processes, and what our footprint is. So Micron is certainly on the forefront of that in the semiconductor industry. We are having some very lofty goals of being net zero in our all of our manufacturing and our operations by 2050. And I know that sounds really far away, but in some regions of the world where we operate, there's simply no access to renewable energy.
No.
So we need to actually build the projects and make it done. But where we do have access to renewable energy, for example, our facility in Malaysia is running 100% all renewable energy. We're building 2 new large manufacturing facilities in the United States. Together with the existing facilities, are going to be running 100% on renewable energy by the end of this year. And so, we have a lot of, goals also with regards to recycling of water and waste, and, that we track and that we share publicly on our website. So a lot of customers are, obviously focused on their own footprint, but they're certainly starting to ask a lot of questions about the footprint of their suppliers as well. And I feel very comfortable answering those questions at the moment because of the very progressive steps that Micron is taking in that field.
Yeah, and obviously more so now. Do you actually see it as part of a real decision-making process for them about who they're going to use? It's actually probably a top 3 or maybe top 5 sort of decision-making thing, along with cost and technology and all these things that go with it. It's really up there now, isn't it?
It's certainly getting there. Yes, we certainly, we're being asked by customers to provide, a lot of the data. There's even customers that are asking us for, the carbon footprint per product. So they say, if I buy 1 DRAM module, what's the actual carbon footprint associated with that? I don't think we're there yet in terms of doing that, a real detailed calculation, but those are certainly the kind of questions that we're starting to get. So it is, in the larger data centers in Europe, it is certainly a big part of their decision making at the moment already.
Yeah, sure. Okay, cool. Thank you for that. So another part that I wanted to touch on, and it's probably something that we speak on probably once a month, and that's the market. So it's the market is very cyclical here in the memory and storage industry, and very up and down. And we've had a very interesting time of it. And as I'm talking about this right now, it might be maybe a little bit trickier for people to get their hands on things. I don't know. Maybe you can explain a bit more, but we've been in and again, correct me if I'm wrong, but a state of oversupply for some time off of the back of the pandemic. But things have changed and they're ever changing. You've obviously Micron, and along with everyone in the semiconductor industry, have suffered some losses, and there's had to be some cut to suppliers to sort of deal with that balance. But can you give you give it to me all the time, Esther, but can you give it our listeners a bit more of an update on the market dynamics right now, specifically around enterprise storage?
Yep. So the situation that we are in today is really the result of COVID, when nobody in the world could get their hands on products, and so everybody just bought and bought and bought as long as they could get something. And what we ended up in a situation is that a lot of the customers, large customers worldwide, ended up with a lot of inventory. And as soon as kind of COVID eased up and shipments started to happen again, those customers then ended up with a lot of inventory in their warehouses, and demand dropped dramatically. Now, in the semiconductor industry, for any semiconductor company, to adjust their output to the demand is a long process. To give you a flavor, to actually make a product from the moment we start what we call a wafer till you actually have a finished good, it's about 3 months. So every time, when there's changes in market demands, whether it's up or down, it always takes the industry time to adjust. And so what we ended up seeing, about a year and a half ago was that the industry, wasn't quick enough in its adjustment to the reduced demand. And so we got into a very severe oversupply situation, which then, made the prices drop, tremendously. And so since the start of 2023, as a result of this, all of the vendors in the semiconductor industry decided to cut their production dramatically so that we would get into a more balanced supply-demand situation. And so that has gone, that supply constraint or limitation in supply has been going on now for about a year. And we're now getting into a market where our customers have gone kind of through that inventory that they had built up, and they're now getting back into a more normal cadence of buying products on a regular basis. And again, I'm talking about all of the markets, whether it's automotive, mobile, data center, right? I mean, at the end of the day, what we sell is, flash and storage, regardless of what end product it's going to go into. And so what happened is that, at the moment, we're getting now into a situation where the market is constrained. There is not enough products being manufactured for the amount of demand that there is, because demand has slowly started to pick up to, kind of regular level, if you will. But the suppliers, there is a limited set of suppliers, are all, if you will, artificially keeping their production low, because of the tremendous losses that they have, seen throughout 2023. To run a semiconductor operation, you're looking at billions of dollars on a quarterly basis. And so that money, all companies, including Micron, but, all of our competitors have lost billions of dollars in 2023. And so the only way to get out of that situation and for everybody to get back into profitability and being, a company that's going to be around in another 5-10 years, means we have to, get the prices back up so that we can turn profitable again. So what we're seeing at the moment is that the market is, if you will, artificially kept constrained, so that prices will continue to go back to the levels where everybody is making money. And that situation will remain throughout 2024. At the moment, all the vendors are, if we look at the NAND market, so the storage market, we're at about 60% utilization rate, and the DRAM market, we're at about 80% utilization rate. And so no vendor will increase its production up until they start, making money again, which means that prices have to go up before, why would you, produce more if you're going to, ship a product that you're losing money on? So the focus of all of the semiconductor companies is to get the prices back up to where they need before they start adding more production. And that really is expected to last at least throughout 2024. Maybe towards the end of 2024 is when we start seeing some release in that. And what that really means is that prices will continue to go up month over month, quarter over quarter. I know that's not something that customers will want to hear. But the reality of it is that if we don't do that, then, in 5 years, customers will not have a supplier to give them products anymore, because, it is not a survivable situation. So that is the market at the moment. We will continue to be constrained, and we will continue to see prices going up throughout. And again, this is not a Micron story. This is really, any DRAM or SSD vendor you will be talking to will be, having the exact same story.
Sure. And just on that, and you work closely with customers every day. So what would your advice be to these customers? Was it a case of working closely with your supplier to plan and forecast for the future?
Yeah, absolutely. Forecast is key, and even more key is backlog, right? Backlog is king. If you tell me you're going to buy it and then another customer places the backlog, then the people in the back end of the business have to make a decision then. So understand that lead times will increase or have increased already. It's not going to be the same situation as in 2023 where we can ship in a matter of days. it's going to be longer lead time forecasting and communication is going to be key, and understanding that prices will continue to go up, and plan accordingly is really what I would recommend anybody in the industry.
Yeah, I think that's the best advice. So no, thank you for that and discussion on the market and a bit of a foresight into what the future might look like there. And something I like to do with guests, depending on the topic and if it fits, is sort of predict a little bit on the future. And I think we can probably do a little bit of that now. So we've discussed a fair amount around the technologies available now and where they're moving. But what sort of trends and technology advancements do you really see being key and massive in the next 5 years for memory storage from your perspective?
Well, I mean, it's all driven by, going bigger, faster, higher.
Yeah.
And AI really is at the forefront of that. So we're certainly going to see on the DRAM side, right, we're going to see more, better, bigger, faster, high bandwidth memory, for those products that go directly, into a GPU. But if you look at the module business, DDR5, we will see this year alone, we'll see, speeds increasing, to 5600, then to 6400, then to 8000 mega transfers per second. Which is just, manic. I mean, a year ago, we were still at 3200 mega transfers per second. We see that. We see, higher capacities, 128 gigabyte, modules, at some point 256 gigabyte modules. And again, all of that is driven by a lot of the AI requirements. As I mentioned at the beginning of our talk, an AI server can have up to 8 times as much memory in it than a regular general purpose server. So it's all about bigger, faster, higher. On the SSD side, NVMe certainly is the main technology that we'll continue to see. PCIe Gen 5 will start to make its inroad this year, really primarily at the hyperscale data centers that are already qualifying some PCIe Gen 5 products, but we'll start slowly seeing that into smaller data centers kind of next year and onwards.
Yep.
And then the other trend that we'll continue to see is these high capacity 30 terabyte and beyond products. At the same time, we'll start seeing some more optimized form factors for NVMe and PCIe that are a little bit different than what we've seen now. So today the two main form factors in NVMe are M.2 and U.3, and we're starting to go towards some slightly different form factors called E3. We have E1.L and E1.S, and now we're moving to something called E3, and that is if you will, it looks like a 2.5-inch drive, but it is, a lot of optimization are done around NVMe and the PCIe Gen 5 bus. So it is slightly different connector, but that, in general, which will be what we're going to see in the next few years. So PCIe Gen 5, E3 form factor, and on the DRAM side, DDR5, bigger, better, faster.
Brilliant. Okay, well, thank you for that, Esther, and thank you so much for your time today. I feel that we covered a lot there, and I'm super excited to get this one out. So thank you again and for your time, and hopefully we can catch up again and see if all of that's come true, and I'm sure it has, and where we are with it all, because this thing moves fast, right?
Yeah, absolutely. It does. I mean, I always, many times I start my whenever I have do a presentation in front of a crowd, I ask people, take a guess what, I sold my very first SSD 25 years ago. It was a 1 gigabyte drive, and I sold it to a military customer for data recording in a plane. And, I always ask, so, take a guess, how much I sold that drive for. And people take a guess, but then when I actually give the answer, everybody is just so flabbergasted. So my very first drive that I sold 25 years ago was $25,000 for a 1 gigabyte drive.
Wow.
So yeah, if you just see how much, in 25 years, right? I mean, 1 gigabyte today, you're looking at 8-9 cents. 10 cents maybe for a high-end drive. So, the world is changing rapidly when it comes to memory and storage technology. And I don't think that, we're anywhere close to the end of that. So very exciting. And, if you like technology, this is certainly an area to keep track of.
Yeah, that's it. I imagine the portfolio back then was a lot easier, considering now we're talking thousands. It's just the pure education and information you have to give people that's best for them, right? There's so many options out there, but there will be something that fits, right?
Yep, absolutely.
So,
absolutely.
No. All right. Well, thank you. And I wish you a good rest of your day, and we will catch up soon.
Thanks so much. You
Cheers,
too.
Esther.
It was a pleasure being here. Thank you so much.
Thank you, Esther.